Ready for a wild ride? We're diving headfirst into the world of probability today. And not just the basic stuff.
Oh no, we're going deep, deep down with the one and only Richard Feynman.
Right. Using his incredible lectures on physics as our roadmap.
We're going to see what this whole chance thing is really all about.
And you know how Feynman is, right? The guy could make physics sing. He had this way of taking the most mind-boggling ideas and making them, well, fun.
He was the master of finding the extraordinary in the ordinary.
Exactly. And that's exactly what he does with probability in Chapter 6.
It's not just about dry equations and formulas.
No way. It's about understanding how our brains naturally make sense of the world around us. Like when he starts by defining probability.
And it's actually pretty straightforward when you think about it.
Right. He says it's our best guess at how often something will happen if, and this is key, if we can repeat an observation over and over again.
Like flipping a coin.
A classic example. We all know there's a 50-50 chance of getting heads or tails.
It just feels right, doesn't it? Even without pulling out any fancy math.
But then, Feynman takes it a step further.
Because it's not as simple as it seems at first glance. He reminds us that probability is subjective.
Subjective. So it's not like set in stone.
Not at all. It's always tied to what we know at any given time. And as we get more information, it can change.
Whoa, so probability is almost alive then.
In a way, yeah. And to really drive that point home, he uses this wonderfully quirky example. He talks about the probability of a ghost being in a house.
Wait, hold on. Now we're talking. I'm picturing Feynman with a proton pack, chasing after ghosts.
Not quite, although that would be amazing. No, it's actually a really clever way to show that probability only works when you can repeat an observation and actually measure the results. You can't exactly design a proper scientific ghost hunt. Or can you?
Maybe that's a deep dive for another day. But back to those repeatable observations. You mentioned repeating them, and that makes me think about Feynman's deep dive into coin tosses. And he doesn't just talk about those simple 50-50 odds. He walks us through this whole experiment, 100 games of 30 coin tosses each.
Can you imagine trying to keep track of all that data? And what Feynman really wants to highlight is that the results don't always match up perfectly with those ideal probabilities.
You mean even if I flip a coin 30 times, I'm not guaranteed to get exactly 15 heads and 15 tails?
Exactly. And that's where we run into this fascinating idea of fluctuations.
Fluctuations. So probability isn't always perfectly balanced in every single little experiment.
Right. Things might even out over a huge number of trials, like thousands and thousands of coin tosses.
So the casinos don't have to worry too much.
Exactly. But in smaller samples, those unexpected swings, those fluctuations, they can happen. And that's where Pascal's triangle comes in handy.
Pascal's triangle. Isn't that the thing with all the numbers arranged in that triangle shape? I remember that from math class.
That's the one. It's not just a geometry tool, though. It's a visual way to represent all the possible outcomes, all those probabilities, in a series of coin tosses. Like, what are the chances of getting 3 heads in a row? Pascal's triangle can show us that.
So it's like a roadmap of chance for coin flips.
You could say that. But what's really mind-blowing is how Pascal's triangle reveals those hidden patterns that emerge from seemingly random events.
Classic Feynman. Finding those mind-bending connections in the things we see every day. But you know he doesn't stop there. We've got coin tosses, Pascal's triangle, and now we're off on a random walk, right?
You got it. Imagine flipping a coin and taking a step forward if it's heads, and a step back if it's tails. That's the basic idea.
That sounds a lot like my morning commute some days. 2 steps forward, 1 step back.
Right. So the question becomes, where does this random walk actually take us?
Literally and figuratively, I'm guessing.
Exactly. Feynman, being the brilliant physicist he was, actually calculated something called the root mean square distance of a random walk. Basically, how far you're likely to stray from where you started after a certain number of steps.
Okay, so after, say, 100 coin flips, how lost am I going to be?
Right. And here's the kicker. This ties directly into one of the most recognizable shapes in all of statistics, the bell curve.
Wait a minute. The bell curve, as in the one teachers use to explain grades.
The one and only. It's formally called the Gaussian distribution, or the normal distribution.
Yeah.
And it pops up everywhere. Student heights, exam scores, you name it.
So we've gone from this simple act of flipping a coin to this elegant universal curve.
That's the beauty of it. And Feynman was showing us that probability isn't just some abstract concept. It's woven into the fabric of our world.
Okay, that's pretty mind-blowing. But I have a feeling it's about to get even wilder, right?
Yeah.
Because next up, we're leaving the familiar behind and jumping into the quantum realm. With Feynman as our guide, of course.
Hold on to your hats, folks, because this is where probability goes from being a helpful tool to the fundamental principle of reality itself. Fasten your seatbelts because the quantum world is where things get really strange.
Well, I'm all buckled in. Hit me with it. I have a feeling we're about to see probability in a whole new light.
You got it. In the quantum world, probability isn't just a tool we use, it's fundamental to how reality works. And one of the best examples of this is the Heisenberg uncertainty principle.
Uncertainty principle. That has a kind of ominous ring to it. What's that all about?
Okay, so imagine you're trying to pin down the location of a tiny particle.
Okay, got it.
The more precisely you try to measure where it is, the less you can know about its momentum, how fast it's moving, and in what direction.
Wait, hold on. You're saying if I know exactly where something is, I can't know for sure where it's going. Isn't that a bit of a problem?
It's not just a problem, it's a fundamental limit. It's like the universe is telling us there are certain things we can't know with perfect certainty at the same time. And that's where probability takes center stage. Instead of a particle having a definite position, we have to think in terms of probabilities. Feynman described it as a cloud of probability.
A cloud. Like a rain cloud. Am I going to get rained on by particles now?
Not exactly. Think of it like a weather map.
Okay.
You know how they show the probability of rain in different areas? Some regions are more likely to get showers than others, right? It's similar with particles. Instead of a pinpoint location, we have regions where the particle is more or less likely to be found.
So instead of saying it's right here, we're saying it's probably somewhere in this general area.
Exactly. And the denser the cloud in a particular spot, the higher the probability of finding the particle there. It's a completely different way of thinking about the world, but that's quantum mechanics for you.
So we're trading uncertainty for probability.
Mm-hmm.
It's like the universe is playing a cosmic game of hide and seek. And speaking of uncertainty, didn't Einstein have something to say about all this? Didn't he believe in a more deterministic universe?
You're right on the money there. Einstein was famously uncomfortable with this whole idea of a universe governed by chance. You know that famous line of his, God does not play dice.
God does not play dice.
Yeah.
Classic Einstein. I always love that quote. So how did Feynman deal with that? He wasn't exactly reaching for the dice himself, but how did he reconcile Einstein's view with his own understanding of probability?
That's a great question. Feynman definitely acknowledged Einstein's discomfort, but he also argued that this probabilistic view was the best explanation we had. He wasn't claiming that the universe is inherently random. He was simply saying that our ability to know certain things with absolute precision is fundamentally limited.
It's a very humbling thought, actually.
Yeah.
Even with all our scientific progress, there's still a fundamental mystery at the heart of things. It's like we're peeking behind the curtain of reality and finding out that probability is the one pulling the strings. And that leads us to some really big questions, wouldn't you say? So if the universe really is playing dice with reality, does that mean free will is just an illusion?
That's the big question, isn't it? And Feynman definitely doesn't shy away from these philosophical implications.
So are we really just along for the ride? In this probabilistic universe, is everything already decided for us?
Well, Feynman doesn't exactly give us a straight answer. He was a physicist, after all, not a philosopher.
Right.
But he does offer a really thought-provoking perspective. He suggests that even if the universe operates on these principles of probability, it doesn't diminish the wonder and mystery of it all.
That's an interesting way to look at it. It's like, just because we know a coin toss comes down to probability doesn't make it any less exciting to watch it spin through the air.
Exactly. And think about it this way. If there is this element of uncertainty baked into reality, it actually makes our choices, our actions, even more meaningful.
Because we're not just gears in a machine.
Right.
We're making decisions in the face of the unknown.
Yeah.
And that makes them all the more powerful.
Exactly. It's not about knowing everything with absolute certainty. It's about embracing the mystery and making the most of the choices we have.
That is a fantastic takeaway from our deep dive into probability with Feynman. He's given us this whole new way of looking at the world.
Absolutely.
One that acknowledges chance and uncertainty,
Right.
while still appreciating the beauty and wonder of it all.
It really makes you think.
It does. So next time you flip a coin or roll the dice, or even just make a simple decision, remember this. Probability is woven into the very fabric of the universe. It's part of what makes reality so fascinating.
I love that.
Thanks for joining us on this incredible journey with Feynman. Until next time, keep those minds curious, and remember, the universe is full of surprises.